All right, so this is the notes for the first part of Chapter 6. Now your homework for this is broken up into two parts, mainly because I recommend we first focus on the simpler part, which is the first few elements of the homework, and then before getting into the more algebraic work. But it's all part of the same lesson, so I'm just going to cover it all here. All right, so generally, the focus of this chapter now is looking at the equations of lines, equations of linear functions. Now, you did this in grade 9 in a little bit of detail. We're just going to go into much more detail and apply it more here. And so a lot of the things we learned from Chapter 5, especially slope, is going to come in throughout this chapter. And so first, when a linear equation is solved for y. Now, solve for y means just like what you see down below, an equation where y is isolated on one side of the equation. Right? Both of these are solved for y. So when an equation is in that form, it doesn't have to be. An equation doesn't have to have y on one side, but if it does, usually you can quickly determine its slope and its y-intercept just by looking at the equation. Now, slope we've learned about already. Right? Rise over run, it's a measurement for how a line changes, or the steepness of a line, or it's the change in a relationship. The y-intercept is where a graph crosses the y-axis. It's where a line intersects, crosses, intercepts, you could say, the vertical axis. And you can see these things in that equation. And the most common way of writing it is we say y equals mx plus b, where m, as we saw before, represents slope. B is the y-intercept. Now again, you don't have to use letters m and b, just that's what the textbook uses, and that's fairly common. And it doesn't have to be in that order. The slope is not the first number beside the equal sign. The slope is the coefficient of x. So you don't want to think that the slope is always the first number. The slope is the coefficient of x. And so let me label some of these things here. So that m is the slope, and b is the y-intercept. So b, the y-intercept is the constant, the term that doesn't have a variable, and slope is the coefficient of the input of the x, just the coefficient. All right. So with that said, as always, the best way of understanding this is to use it. And so I have a variety of questions here. For each one of these, I want to graph the line just by analyzing the equation. Now again, you may have done this in grade 9, and the more you covered of this in grade 9, the easier this is. And I've noticed some students have a really good memory of this in grade 9. So I want to graph the equation y equals 2x plus 1. Now it's not wrong to create a table of values, x, y. Pick some numbers for x, 0, 1, 2, 3. Plot them out for y. Get some dots. Connect your line. And that is OK for a start, just for a start. That is what you would have learned in grade 8. When you looked at this a little bit, that's how you would have started in grade 9, but you may have learned more. Past today's lesson, that's no longer even OK. It's OK for a start, but it's really time-consuming, and it's not what I'm trying to pay attention to. The whole point is, what can we analyze just from the equation? And so looking at this equation, I can see the slope is 2, and the y-intercept is 1. So what does that tell me? That tells me this line, first of all, the y-intercept is 1. I know this line crosses through 1 on the y-axis. So I can plot that point right now. If I look at my coordinate plane here, here's 1 on the y-axis. I know my line will go through that point. Now, just like that, I know 1 point. And when you want to sketch a line, or you want to visualize a line, all you really need are 2 points. So if I can find one more point this line goes through, grab my ruler, and I'm all good. So next I look at the slope. So the slope is 2. So let's remember what slope means. Slope is 2, which is the same as 2 over 1. If I write it as a fraction, then I can see the rise, and I can see the run. And also, it's a positive number, so I know my line's going up. So I know my line's going up through that point, but a little more detailed, it's going not just up, it's going up by 2 over by 1. So I'm going to look here, I'm going to count up 2 over 1, and I know it goes through that point. And it's a line, so it never changes the direction. So it should be pretty easy to continue this pattern visually in either direction. At this point, I got more than enough dots to make my line, so I'll grab my ruler, draw arrowheads, and there's the equation for the line of y equals 2x plus 1. That's what that line looks like. And if I can see the slope and the y-intercept, I should be able to visualize it quite quickly. All right, so for the next one, y equals negative 1/2 x plus 5. And in fact, actually, what I'd recommend is, before I go on, I would recommend trying a few of these in your booklet before I do too much, if you can. That's it. My slope is -1/2, so my slope is going down. My line's going to be going down. My y-intercept is +5. I'm going to plot that first. +5 is right there. The slope is going down. It's going down 1 over 2. So the rise is -1. The run is +2. I will mention another way of looking at it that ends up being the same. I think this is the most straightforward way. When you see the whole fraction is negative, just treat that as the rise being negative, although you don't have to. But you just have to treat one of them as being negative. Usually most people think of the numerator as being negative. Because, for example, -1/2 is the same as -1 over 2. Those are equivalent. It's also the same as 1 over -2. The last one looks the weirdest, in my opinion, just because people don't usually put a negative in the denominator if they don't have to. But those are all equivalent. So I'm choosing to think of it like this, down 1 over 2. But again, all these values I just wrote down are equivalent to one another. -1/2 equals -1 divided by 2, which equals 1 divided by -2. So let's plot this. Down 1 over 2, down 1 over 2. There we go. And do that a few more times. I grab my ruler, and I got my line. All right, notice how quick that was. Let's look at the next one. 8 minus x, or y equals 8 minus x. So first of all, the 8 is not the slope. 8 is the y-intercept. It's a constant. My slope is the coefficient of x. So the coefficient of x, it might look like there's nothing there, but it's -1. Remember, if you don't see a coefficient in front of a variable, that represents 1. And so if it's negative, in this case, -1. So I'll get to the slope in a moment, but the y-intercept is 8. I'll draw that right now. There we go. The slope of -1. So what does a slope of -1 look like? It's like -1 over 1. And so I'm going to go down 1 and over 1. So down 1 over 1. Pretty easy to visualize. Down 1 over 1, and so on. There's my line. Notice all of these so far have been really quick once I know how to analyze my equation. And ideally, I mean, honestly, more important than being able to draw the line is being able to visualize it just by looking at an equation. That's something computers can't do. Computers can graph an equation way better than a human ever can in terms of just making it look pretty. But a computer can't look at an equation and get a sense for what's going on. That's our goal. Our goal is to have a sense for what's going on. And one of the best ways of showing me you have a sense is to draw something. All right, let's look at these examples. This one's a little different. This only is just y equals -3. There's no x. So now you got to think to yourself, is that -3? Well, what is it? Well, it's a constant. I mean, it's still the constant. There's no variable there. So that is my y-intercept, -3. But there's no slope. If there's no slope, that means your slope is 0. No slope. I mean, it's not wrong to add something. It's not wrong to add plus 0x here, right? If I do that, my equation's still equivalent. 0 times x is 0. It's kind of silly, but it makes it more clear that there is no slope. There is a 0 slope. And remember, a 0 slope is horizontal. So I can draw my line right now. I know my line is going to go horizontally through this point. So horizontally is sideways. And there we go. This is what the line of y equals -3 is. It's a horizontal line. All right, and so the next one is kind of the other way around. There's a slope, but there's no y-intercept. So that's my slope. But what's my y-intercept? Because if I can't really use my slope until I have a point first. Oh, I got to learn how to spell here. Take 3. So the slope I can see is -2 over 3. Down 2 over 3. But from where? Well, if I want, I could, like before, I can create a constant, and my constant will be 0. It's not wrong. Like in the last one, it wasn't wrong to add 0x, and if it made the slope more obvious, it's probably a good idea. In this case, it's not wrong to add 0. It's kind of silly in some ways, but perhaps it makes the constant more clear. The y-intercept is 0. And so now, from here, I can now use my slope. I want to go down 2 over 3. Down 2 over 3. Or I can go up 2 and backwards 3. It all follows the same line. Again, to draw a line, you just need 2 points. I would generally recommend plotting more than 2. But all you really need are 2 points on a ruler to draw a line. All right, last one on this front page. Y equals x over 2. What's going on here? Well, first of all, there's no constant like before. So I'll put a plus 0. I know this is going through 0, 0. OK, very important point. But what's my slope? Well, my slope is not 2. It's not 2x. It's x divided by 2. And so what may make your slope more obvious is one of these two things. First, remember, if you look at just the x, there's no coefficient in front of it, which means there's actually a 1 there. And so you can always write that in, and quite often it's helpful because it probably makes the slope more obvious. The slope I can see is 1 over 2. Now this equation is the same as 1 over 2x. 1 over 2 times x is the exact same thing as x divided by 2. Multiplying by a half is the same as dividing by 2. And so I can now see in either of these equations, I could either rewrite it or I can just put a 1 in front of the x, but either way I can see the slope is 1 over 2, positive 1 over 2. So my line's going up 1 over 2. And I already have a starting point. So up 1 over 2 looks like this. And I'll draw a few more, and that's all I need. There's my graph of x over 2. All right, on the last other page, the last 3, there's something different about these 3 compared to all the previous ones. And notice I have a bit of space right here. There's a reason for that. That's because I'm going to have to do a little bit of algebraic work for each of these. And that's because none of these are solved for y. Remember, if I go back to the very start, if an equation is solved for y, right, when a linear equation is solved for y, then you can just look at it and see the slope and the y-intercept like I've been doing for the last 5-10 minutes. And if it's something that's solved for y, you should have an equation where, again, y is isolated on one side all by itself. That's not the case with any of these. On none of them is y all by itself. So first, I need to isolate y. I need to find a way algebraically to get y by itself. And we always alter equations algebraically by adding, subtracting, multiplying, dividing values to both sides, just like when solving an equation. And so for this first one, x plus y equals 3, I want to get y by itself. How do I do that? It's actually quite pleasant. All I got to do is subtract x from both sides. If I subtract x from both sides, on the left-hand side, I just have y. That's what I want. On the right-hand side, I have 3 minus x. Now, 3 minus x are not like terms. I can't put them together, so it's just 3 minus x. There we go. Now I got my equation. The 3 is my y-intercept. My slope is negative 1. And I got everything I need. And so now I can plot this. As usual, I start with my y-intercept of 3, which is right here. And then a slope of negative 1. Remember, a slope of negative 1 means a rise of negative 1 over a run of positive 1. Or you can look at it the other way around if you want. You could think of it as going up 1 and then backwards 1. But I will generally never recommend that. But I think it's, personally, I'm just going to go down 1 over 1. And so down 1 over 1. Oh, where'd you go? Come back here. There we go. So down 1 over 1. Do that a few times, grab my ruler, I got my line. And the second part of your homework for this lesson is more questions like this, where you have to do some algebraic work. In this case, it was a single step. And all utilizes those same things we reviewed at the very beginning of this course, those key ideas from grade 9 of working with equations. So now the next one, 2x minus 3y plus 12 equals 0. I want to isolate y. There's a few things I could do. I could, although I'm going to erase this eventually, I could minus 2x from both sides. And then I could subtract 12 from both sides. And I would have negative 3y left on the left-hand side. That's OK. However, I don't have to have y on the left-hand side. I can have y, just has to be by itself. It has to be isolated. And so instead, what I think is faster is just to add 3y to both sides. And in doing so, I have 2x plus 12 on one side and just positive 3y on the other. And the good thing about doing this as well is that everything's a positive now. If I subtracted 2x from both sides, for example, and subtracted 12, I'd have a whole bunch of negatives. And I'm sure we're all aware it's much easier to make mistakes with negatives than with positives. And I don't want us to think robotically here that you have to have y on the left-hand side. Not at all. Now I just have to have y by itself. So now I want to cancel out just the 3 in front of the y, the 3 times what's in front of the y. So I want to divide this by 3 and divide everything by 3. If I do that, on the left-hand side, first I have 2x over 3. Don't decimalize it. You can actually see the slope. The slope is 2 over 3. So I'm just going to write it as 2x over 3. It's quite pleasant having a fraction in front of the x when you're dealing with an equation. Next, 12 over 3 is 4. And then on the right-hand side, I have just y. Now my equation, I can see 4 is the y-intercept. That's the constant. My slope is positive 2/3, up 2 over 3. And now I can plot this really quite quickly. However, clearly, if I make an algebraic mistake isolating y, my line will be wrong. Quite often I'll have the wrong slope. It'll be going the wrong direction because I missed a negative somewhere. But that's it. Y-intercept of 4 right there. And then slope of 2/3 up 2 over 3. So do that a few times. That's enough. I got my line. Keep in mind, though, just like when solving an equation, there's always more than one way of doing it. And so don't look for the way to do it. But after a while, hopefully you could feel confident about what's a fairly direct way to not give yourself needless extra work. So last one here, 1.5x minus y equals 3. So again, I want to isolate y. I could subtract 1.5x from both sides. What I'm going to do instead is I'm going to add y to both sides, which will bring y to the right-hand side. And while I'm at it, I'm also going to subtract 3 from both sides. Okay, I'm doing 2 steps at once. And again, if that's a little too much, just do 1 step at a time. So on the left-hand side, my y's cancel out. I have 1.5x take away 3. They're not like terms, so I'm just going to write 1.5x take away 3. On the right-hand side, all I have left is y. So that's what I want. So now I can see my slope and my y-intercept. So my y-intercept is -3. That's the constant term. I'll draw that right now. -3 in the y-axis, right there. OK. My slope I can see is positive. It's 1.5, which is going up. But how do I show a slope of 1.5? One thing that's not wrong, but I don't recommend it, is to think of 1.5 as being 1.5 over 1. It's not wrong. You have to count up 1.5 steps, go over 1. It's just more pleasant to count in whole numbers than half of a step. So it's not wrong, but especially on a grid that's quite small, it's pretty tricky to count half a step a few times accurately. It's not impossible by any means. However, what I think is better is to take 1.5 and change it to an improper fraction. And just think, what fraction is the same as 1.5? And you could write 1.5, right? That's correct. But that's not so useful in for slope because I want a single fraction, not this mixed number. But 1.5 is the same as 3/2. And that's what I like the best, personally. 1.5 is the same as 3 over 2. And so I'm just rewriting my equation like this, just to make the slope more obvious. And I would rather count up 3 and move over 2 than count up 1.5 and over 1. But it is the same thing in the end. But I'd like to count by whole numbers. And so 3 up over 2, right there. Do it again, one more time, and I'm done. Notice when dealing with slope, it's one of those times that your life is actually easier when dealing with fractions. Whereas a lot of you are probably used to the idea that you prefer decimals over fractions. But when dealing with slope, especially when visualizing it, it's quite pleasant to visualize with a fraction because you can see the rise over run quite readily, especially for your fractions in lowest terms. And that's it. All right, so the homework for this again is broken up into 2 parts. Generally, the first part, which is quite short, is questions like this, where they're more straightforward. And then the later ones, they're a little bit different, like the latter ones. And then have some algebraic work, maybe. All right, super important lesson that a lot of you probably learned about in grade 9, but whether or not you did, it's an important lesson. So